Today we are going to do a topic still involved in sharing stress. We're still in the topic of sharing stress. But now we are going to do T1 analysis. Okay. T1 analysis we have not learned before, and it's one of the in terms of difficulty, it's more difficult than thick wall or non-thin wall. Okay, so we're going to do what? T1 analysis. Okay, I'm going to incorporate another 3 more rules. Okay, so whatever we learn in non-thin wall can still be used in thin wall. Okay, so we are going to look into thin wall analysis now. So the formula that we are going to use, there are 2 formulas that you're going to use. And you guys will say, yeah, I've seen those formulas before. One, something's not working. Cannot zoom out. Okay. So the formula that we are going to use okay, again, 2 formulas that we're going to use shear stress is equal to V or IT. So formula is still the same, where shear flow is equal to VQ over I. Okay. So in thin wall analysis, there are 2 configurations. And I posted these diagrams for you guys. And the first one is known as box beam. And the second one is known as white flange. Okay. So you can see over here on the left-hand side is what we call a box beam. And the right-hand side is known as the white flange. Okay. From here, later on, we're going to design the shear flow for more complicated structure. Okay. What do I mean by more complicated structure? Within the next 5 minutes, you are going to be able to design the shear flow for the diagram on the center, the left center, and the third column. If you how to design the shear flow, just the rules designing shear flow in those diagrams are really, really easy. Okay. Only mechanical engineers will do this. Human will do this. Okay. I don't know why, but maybe it's us. So what are the rules? Okay. So as I mentioned before, we have to know how to design the shear flow. Okay. So this analysis is all depending on the what? Design of the shear flow. So we are going to have rule number 6. By looking at this diagram, we can create three more rules or two more rules. Okay, rule number 6. Or before we do rule number 6, let's do rule number 1 first. Rule number 1, P and Q are what? Constant. That is still valid. Okay. Rule number 2, any idea? What's rule number 2? Oh, V and I are constant, you're right. Okay, V and I are constant. What is rule number 2? Can you remember? I can't remember now. What's rule number 2? The datum set the what? Is it datum is at geometric centroid? That still stand. Okay, so this rule still are there. Rule number 3, analysis starts from furthest distance from centroid. Rule number 4, Q cannot cross the what? Centroid. Rule number 5, Q flow in one direction only. Still valid. Or still what? Valid. Okay. The next thing, to apply thin wall, we need to have more things, okay? So what you see over here, this is known as the what? Major web. Okay. So rule number 6, what you can see about the major web, you only can see one direction only. Right? The major web only has one direction. So in this context, rule number 6, the major web controls the shear flow direction. Okay, that's rule number 6. Rule number 7. Okay. What you see over here for box beam, this is our terminal. So now the terminal is not a line. The terminal is a what? It's a dot. Okay, so over here, again, this is our terminal. So terminal is where in thin wall, terminal is where the shear flow starts, or the what? Shear flow what? Ends. Are we clear? Okay. So in a box beam, you only can see how many terminal? 2 terminal. Flange, you have how many terminal? You got terminal number 1, you got terminal number 2, you got terminal number 3, you got terminal number what? Number 4. So again, at the terminal, the shear flow is equal 0. So where all the dots are, the shear flow are equal to 0. Okay. Over here, I'll put note. The longer the red arrows, the higher it's what? Magnitude. Okay, I will highlight that. And finally, rule number 8. You all have seen this before. The wall thickness is always perpendicular It is always perpendicular to the shear flow directions. So what do I mean by that? Okay, the wall thickness is always perpendicular to the shear flow direction. Let's say we want to pick a point down here known as alpha. Okay, over there, this point over there, I want to pick is known as alpha. This is going to be our what? Our thickness. Are we clear? If over here, this point is known as our beta, this is known as our what? Thickness. Okay. So you can see that it is very different from what? It's very different from thin wall, non-thin wall analysis. Okay, so for non-thin wall analysis, okay, for non-thin wall, okay, so over here, I will do this for non-thin wall. So this is for non-thin wall analysis. Okay, for non-thin wall analysis, if we want to find the thickness of alpha, what is the thickness we take? This is the what? This is our thickness. Yes or no? Right. So for non-thin wall analysis, again, for the I-beam, okay, from an I-beam, if we want to find this point over here, beta, this is our what? This is our thickness. Are we clear? Okay. So some of you may say, when do you use thin wall and when do you go to non-thin wall? There's no standard regulation for it. As engineers, we have to do both. Okay, we have to do both non-thin wall and thin wall analysis. Are we clear? The trick about thin wall analysis is to design the what? Design the shear flow. Okay, let me do an example for you. And then we are so far going to do active learning. Okay, let's look at this example. So this is example number 1. We're going to design the what? Shear flow. The first thing when we design the shear flow, we sketch our centroid. So this, I'm going to assume somewhere around here, this is our geometric, okay, our geometric centroid. We're going to apply the rule where the major web controls the shear flow. Okay, so now if we have V over here, right, we have V over there. I do apologize for this. Now, if we have V over here, okay, this section over here is known as our what? Major web. Okay. So the shear flow will flow, the major web will control the what? The shear flow. So we do this first. The major web will control the what? Will control the shear flow. Straightforward. Then we have left and right. Okay. We have the flange. So how the flange go? Because the major web is like the fluid flow. Okay, fluid flowing down. Okay. So whatever that is above the major web, okay, so I call this top, I call this bottom. It will do this. So anything that is above the major web, it will flow. So any flange, okay, so these are the flange. So any flange that is above the major web, the shear flow will go in. Any flange that is below the major web, the shear flow will go out.